Today, we're going to talk about something that's, one of the biggest challenges in artificial intelligence. We're moving beyond just asking what an AI knows, and we're starting to radically change how it thinks. We're looking at some brand new architectures that are designed to give AI something it's desperately needed: genuine, flexible reasoning.
So let's just get right into it, because this is a question that I'm sure you've asked yourself. You've got these incredibly powerful AIs, right? The large language models that run all the popular chatbots, and you give them what seems like a simple logic puzzle, and they just fall apart. They go completely off the rails. So why does that happen? Well, the answer really gets to a fundamental limit in how they're built today.
And this just nails the problem perfectly. Think about how you would solve a Sudoku puzzle. You put a number in a box, you follow that logic, and whoops, you hit a dead end. You realize your first guess was wrong. So what do? You backtrack, you erase it, and you try a different path. Today's AIs, they can't do that.
And this brings us to what we can call the irreversible mistake. It's the formal name for this problem. Once a large language model makes a decision, once it puts that number in the Sudoku grid, that decision is locked in. It has no way to go back and fix an early mistake, even if everything that comes after proves that first step was a total blunder.
The reason for this is that they operate on what's called a single forward pass. It's like they're just thinking in a straight, irreversible line. They generate one word, then the next, and that famous chain of thought might look like reasoning, but it's really just a longer, one-way street with absolutely no U-turns allowed.
So the big question is, how do we fix this? How do we give AI the ability to pause, to second-guess itself, and to correct its own mistakes? Well, the good news is the research community is already on it, and they're exploring two really powerful and really different paths forward.
Okay, so this first path is, it's basically about creating a kind of hybrid brain for AI. It's a field known as neurosymbolic AI, and the whole idea is to combine two completely different ways of thinking about intelligence.
So on one hand, you've got symbolic AI. This is like the old-school, classic AI. It runs on hard-coded rules, formal logic. It's super precise, but it's also really brittle. And on the other hand, you have sub-symbolic AI. This is what we're all familiar with now, the neural networks. They are amazing at spotting patterns in huge amounts of data, but they don't have that strict logical backbone.
So what neurosymbolic AI tries to do is fuse these two together. The dream here is to get the intuitive, pattern-matching genius of a neural network and combine it with the rigorous, rock-solid logic of a symbolic system. It's kind of like trying to build a model that has both that fast, gut-feeling system 1 thinking and that slow, careful, let me double-check my work system 2 thinking.
Now, if you look at where the research is actually focused, it gets pretty interesting. Based on a huge review of papers from the last few years, you can see that the vast majority of the work, a whopping 63%, is just on the basic mechanics of learning and inference. And that makes sense, right? You got to get the engine running first.
But here's the catch. This also shows us some pretty big gaps. Really critical stuff, like making these systems understandable and trustworthy. Well, that's getting way less attention. And the most mind-bending area, metacognition, which is the AI's ability to actually think about its own thinking. That's barely being touched at just 5% of the research. That's a huge opportunity just waiting there.
All right, so let's check out the second path, which builds a totally different kind of solution. Instead of trying to smush two types of AI together, this approach completely re-engineers the AI's architecture so it can think iteratively, or you could say, in loops. This brings us to something called Recursive Language Models, or RLMs. And the core idea here is so simple but so powerful. An RLM can basically call a copy of itself to go solve a smaller piece of a bigger problem. So instead of one long, straight chain of thought, it creates this branching tree of thoughts. It tackles each little branch, solves it, and then pulls that answer back into the main problem.
Let's just walk through how this actually works. So here, the RLM gets a complex task. But notice its first move isn't to start spitting out an answer. Nope, the first thing it does is analyze the problem itself, kind of like how you would read all the instructions first. It actually writes a little piece of code just to look at the data structure so it knows what it's dealing with.
Okay, now this is the really cool part. This is where the AI starts to act like a programmer. It doesn't just try to brute force the answer, it builds its own tools to solve the problem better. It creates a repeatable process, a function that can handle each little piece of the data. It's breaking one giant problem down into thousands of tiny, identical, and most importantly, solvable little tasks. And finally, once it's built and tested its tools, the RLM just runs the plan. It processes all the data in chunks and puts all the little answers it got from the subproblems together into one final solution. It's a true problem-solving workflow from start to finish.
So you see what's so critical here? This whole looping, recursive process is what gives the AI the power to handle incredible complexity. It can break things down, it can check its work on the small pieces, and it can even rerun a step if it needs to. This is a kind of reasoning that it's just not possible for a standard linear model.
At the end of the day, both of these paths, the hybrid brain and thinking in loops, they're both pointing to the same place. They're pointing toward a new era for AI, one that's going to be defined not by how much information it can memorize, but by its ability to genuinely reason.
And this quote just captures that shift perfectly. LLMs compress knowledge. Recursive models learn computation. For the last few years, the big race has been about who can build a bigger model to cram in more of the world's knowledge. But the future is about building models that can actually perform computation, that can think and problem solve on the fly.
This is really the big idea, the main takeaway. We're shifting from building AIs that are like super-powered encyclopedias to building AIs that are like problem-solving engines. The entire focus is moving away from memory and onto the actual process of thinking itself.
And this brings us right back around to that key research gap we spotted earlier, metacognition. You know, this is really the holy grail. It doesn't matter if you get there with a hybrid neurosymbolic brain or a recursive model. The ultimate goal is to create a system that actually understands its own thought processes and can manage them.
So, as we wrap this up, I'll just leave you with this question to chew on. Forget about an AI that just knows a bunch of facts. What does our world look like when we have an AI that can recognize when it's uncertain, that can backtrack from its own mistakes, and that can consciously choose a better way to find the truth? Because that is the leap that we are on the verge of making.